My name is Joe Dermody, and I am a Solar System Ambassador in a voluntary educational outreach program sponsored by NASA, the Jet Propulsion Laboratory, and the California Institute of Technology. During the 8 solar eclipses I have experienced so far, I have stood in the shadow of the moon for a total of 37 minutes and 57 seconds. On Monday, April 8th, I hope to add another 4 minutes and 27 seconds of shadow time to that total. I am an umbrophile, and I hope that this presentation will convince some of you to become as addicted to solar eclipses as I am. Astronomical events, including solar and lunar eclipses, were often depicted in Paleolithic art. This drawing of a total solar eclipse that occurred on November 30th, 3340 BC, is etched into a rock in an Irish cave. That eclipse occurred almost 5,365 years ago. After you personally experience a solar eclipse, it is easier to understand how ancient humans were awed or even terrified by them. On the left is a drawing of a total solar eclipse that crossed Europe and the Middle East in August of 1654. On the right is a map published by Sir Edmund Halley of Halley's Comet fame, predicting the path of the April 22, 1715 total solar eclipse. Halley wrote on his map, a request to the curious to observe what they could, but more especially to note the time of continuance of total darkness. Both of these maps were surprisingly accurate with regard to both the timing and paths of the total solar eclipses. Astronomy is the oldest of the sciences, and there are countless ancient observatory sites around the world. The sky has always served humans as a natural, precise calendar and clock. Ancient astronomers were often religious leaders. Their ability to predict the timing of solar and lunar eclipses was frequently essential to their positions of leadership. Ancient people navigated across vast unknown oceans, relying on their intimate knowledge of the skies. The total solar eclipse of June 8, 1918, was a welcome distraction from World War I. This Denver Post article showed the times of totality for cities along the eclipse path. During totality, when the moon is fully covering the sun, is the only time we see the solar corona, which can extend for over 2 sun diameters. Corona means crown, and many important scientific discoveries have been made studying the corona during totality. During the total solar eclipse of May 29, 1919, Sir Arthur Eddington led a team of scientists to West Africa who were able to confirm Albert Einstein's theory of general relativity. Eddington was the first scientist to understand that the energy of our sun comes from nuclear fusion. The core of a star, such as our sun, is the only place where there is enough gravitational pressure for nuclear fusion to occur. Nuclear fusion is when atoms of hydrogen are squeezed together to form helium, releasing tremendous amounts of energy in the process. This drawing is not to scale. Although the diameter of the sun is 400 times larger than the diameter of the moon, the sun is also 400 times further away, meaning they both appear the same size to us. Total solar eclipses can be emotional, spiritual, even miraculous events when experienced in person. Even the best photographs or video fail miserably to convey the power of an eclipse. Eclipses are an experience for your senses, not just a sight for your eyes. This drawing is not to scale. The moon's orbit around the Earth is inclined slightly to the path of the sun in the sky. There are at least 2 solar eclipses each year, but never more than 5. Because 70% of the Earth's surface is ocean, solar eclipses occur more often over oceans. Eclipses also occur over polar regions or other sparsely inhabited regions. 2 weeks before the April 8th total solar eclipse, on Monday, March 25th, there will be a penumbral lunar eclipse visible from North and South America. Lunar eclipses, where the moon passes through the shadow of the Earth, occur during a full moon, while solar eclipses, where the shadow of the moon sweeps across the Earth, occur during a new moon. During a total solar eclipse, the only place you will experience totality is within the path of the umbra, the dark central shadow of the moon. Because the moon's orbit around the Earth is slightly elliptical, as is the orbit of the Earth around the Sun, the geometry of every solar eclipse is different. For those reasons, the length of the partial phases and totality vary from eclipse to eclipse. The umbra of the April 8th eclipse is about 115 miles wide and will be moving across the surface of the Earth at more than 1,500 miles per hour when it first reaches Texas. Over the course of each month, the apparent size of the moon varies by about 12% because of the moon's slightly elliptical orbit around the Earth. If a solar eclipse occurs when the moon appears larger, then the time of totality will be longer and the sky will appear darker. The April 8th total solar eclipse will offer a maximum time of totality of 4.5 minutes in Mexico. The longest duration of totality possible during a total solar eclipse is 7 minutes and 32 seconds. During a total solar eclipse, such as the April 8th eclipse, the larger apparent size of the moon completely covers the sun, allowing us to see the solar corona, as well as eruptions from the surface of the sun called prominences. During an annular solar eclipse, such as occurred last October 14th, the moon appears smaller than the sun, leaving an annulus or ring. Annular eclipses are also called ring of fire eclipses. While impressive and beautiful, you will not see the corona or prominences during an annular solar eclipse. This may look like a blank graphic, but it shows the Earth on the left and the moon on the right to scale. The moon is about 239,000 miles from the Earth on average. However, the moon is relatively close to the Earth and is so large compared to the size of the Earth that the Earth and moon are considered a double planet, the only one in our solar system. The center of gravity of the Earth and Moon, called its barycenter, is more than 1,000 miles beneath the surface of the Earth. During a partial solar eclipse, the Moon passes in front of, but does not completely cover the Sun. During a total solar eclipse, the Moon completely covers the Sun. During an annular solar eclipse, the Moon appears slightly smaller than the Sun, leaving a ring of sunlight. Different phases of an annular solar eclipse: before, during, and after totality. An annular solar eclipse peeks out from behind clouds. You can see why they are sometimes called ring of fire eclipses. An annular solar eclipse as seen from a Japanese spacecraft through a hydrogen alpha filter. Some amateur astronomers have telescopes with hydrogen alpha filters that offer similar views of the sun. During the lengthy partial phases of a solar eclipse, as the moon appears to slowly cover and uncover the sun, properly filtered solar telescopes can provide amazing views of the moon, covering and later uncovering sunspots, prominences, and other solar phenomena. I suggest experiencing eclipses with an astronomy club, at an eclipse festival, or at a science center where there may be solar telescopes offering safe and spectacular views that are similar to this. During a hybrid solar eclipse, as the shadow of the moon sweeps across the surface of the Earth, the eclipse alternates between an annular eclipse and a total solar eclipse. This table lists the 8 solar eclipses of all types from 2023 through 2026. There are no fewer than 2 solar eclipses every year, but no more than 5. NASA's Scientific Visualization Studio at the Goddard Space Flight Center produced these accurate, to-scale animations showing the orbit of the moon relative to the Earth, which is shown in the center. Notice the elliptical orbit of the moon around the Earth that is also inclined relative to the Earth's orbit around the sun. When you see, in this to-scale animation, just how small the umbra, the darker central shadow cast by the moon is, it shows how amazing it is that total solar eclipses ever occur. Total solar eclipses did not occur in the distant past, and they will stop happening in the distant future because the moon is slowly moving away from the Earth, meaning the moon will not appear large enough to fully block the light of the sun as seen from the Earth. Humans are a relatively new species on the Earth, and the fact that we are here during the time of solar eclipses is a truly remarkable coincidence. At an eclipse, you may hear people shout out, "First contact," which is the exciting moment the disk of the moon first appears at the edge of the sun. The partial eclipse phases before and after totality take approximately 75 minutes as the disk of the moon slowly appears to cover the sun before totality, and another 75 minutes as the disk of the moon slowly appears to uncover the sun. In a total solar eclipse, totality begins at second contact and lasts until third contact. During totality, and only during totality, it is safe to observe the sun without wearing eclipse glasses, and you may also carefully use binoculars. The sun is not more harmful during a total solar eclipse. The very real danger is that you are more likely to look directly at the sun for extended periods of time, or worse, use optical equipment to observe the partial eclipse phases, risking permanent eye damage which can occur in seconds without you feeling any pain. Throughout the lengthy partial phases of an eclipse, before and after totality, eclipse glasses must be worn to observe the sun. Only ISO 12312-2 eclipse glasses or filters from a reputable source should be considered safe. Do not use welder's goggles, smoked glass, photographic or X-ray film, unexposed, exposed or developed, ordinary sunglasses or multiple pairs of sunglasses, neutral density or polarizing filters, such as those made for camera lenses, space blankets, potato chip bags, DVDs, CDs, or any homemade filters.
Are your eclipse glasses safe for looking at the sun? Let's check to see if your eclipse glasses can handle the heat or if they need to stay inside. First off, never check your eclipse glasses with the sun. That's a good way to injure your eyes. Take your eclipse glasses and find a bright light, like a lamp or a flashlight. Hold your eclipse glasses up to the light and look through them. The light will appear extremely dim or not appear at all when looking through the glasses. For example, you should only be able to see the filament of a light bulb, but not the glow surrounding the bulb. Also, if your eclipse glasses have any marks or scratches on them, don't use them. If you have older eclipse glasses from a previous eclipse, give them a check to make sure they haven't been damaged or scratched. All safe eclipse glasses will meet the ISO 12312-2 standard. It's best to store eclipse glasses in a safe place where they won't become scratched or punctured. Remember, never look at the sun without eclipse glasses or a solar filter. Be safe and happy sun viewing, everyone.
During the partial phases, before and after totality, do not use any unfiltered optical devices, including binoculars, telescopes, or cameras with an optical chain viewfinder system found in many reflex cameras. During totality, which is the brief time the disk of the moon completely covers the sun, it is safe to remove eclipse glasses or filters and carefully use optical devices, including binoculars, telescopes, or optical cameras, but only during totality. Children must be closely supervised during all phases of a solar eclipse. They should not be allowed to hold or play with binoculars or telescopes at any time.
Solar eclipses occur when the moon gets between the Earth and the sun, allowing the moon's long shadow to intersect the Earth. This is the April 8, 2024 total solar eclipse. The central part of the shadow, called the umbra, sweeps across the surface at more than 1,500 miles an hour. It would move even faster if the Earth weren't also rotating in the same direction. The path of the umbra is known as the path of totality. People in that path see the moon completely block the sun, turning the day into night and revealing the sun's outer atmosphere, the corona. The umbra is over land for just an hour and 40 minutes before moving into the North Atlantic and then skipping off the edge of the Earth.
All solar eclipses begin when the umbra, the dark central shadow of the moon, first touches the Earth at sunrise somewhere on the Earth's surface, and all solar eclipses end at sunset when the umbra lifts from the Earth. This animation shows how the length of totality varies along the path of the eclipse. Maximum duration of totality during the April 8th eclipse occurs in central Mexico at the midpoint of the eclipse. The umbra will sweep across 15 states from the border of Texas and Mexico to the border of Maine and Canada in only 68 minutes. This extremely accurate animation was produced by NASA's Scientific Visualization Studio and the Goddard Space Flight Center, showing the entire path of both the moon's umbra and penumbra during the April 8th total solar eclipse. At the beginning and end of a solar eclipse, the umbra is elliptical. Only at the midpoint of the eclipse is it a circle. Considering the crude photographic technology available to astronomers in 1851, this daguerreotype photo is remarkable because it is the first photo to show solar prominences and the corona. This composite photograph shows the final moments before and after totality, when the last rays of sunlight passing through mountain valleys along the edge of the moon create a phenomena called Bailey's beads. As impressive as this image is, your eyes will provide an even better experience because your eyes show far more detail and you see in 3 dimensions, not just 2. A total solar eclipse is the only time that the moon will appear as a sphere instead of a flat disk. Note the red solar prominences along the edge of the sun's chromosphere or outer atmosphere. The sun's corona can be seen as extremely fine hair-like lines. Different phenomena in the solar corona are color-coded here to separate them for analysis, not just to create a beautiful photo. During totality, the only time it is safe to look at a total solar eclipse without protective solar glasses, prominences can usually be seen with your unaided eye. They can also be safely observed during totality using binoculars, but the moment Bailey's beads reappear at the end of totality, you must immediately stop using binoculars or optical cameras and wear solar glasses again. Never use binoculars in combination with solar glasses, either in front of the binoculars' objective lenses or behind the binoculars' eyepieces. Special solar filters are necessary for using binoculars or telescopes during the partial phases of a solar eclipse. Mid-totality during the August 11, 1999 total solar eclipse, showing red prominences all around the edge of the sun. Because the April 8th total solar eclipse occurs near a solar maximum, the corona and prominences could be even more spectacular than this. A sequence of photos from first contact at the top to the very brief diamond ring effect, followed quickly by Baily's beads, and then second contact at the start of totality. Mid-totality is shown in the center photo. The beautiful diamond ring effect occurs moments before and moments after totality. Eclipse glasses must be worn throughout the diamond ring effect and Baily's beads. A French astronaut took this photo from the Russian Mir space station of the moon's umbral shadow crossing Europe during the August 11, 1999 total solar eclipse. Astronaut Don Pettit took this photo of the umbra crossing the Pacific Ocean from the International Space Station on December 4, 2002. Almost 10 years later, astronaut Don Pettit took this photo from the International Space Station of the umbra, also crossing the Pacific Ocean during the May 20, 2012 total solar eclipse. The total solar eclipse of August 21, 2017 was called the Great American Eclipse. Approximately 17 million people experienced that eclipse as it swept across the United States from Oregon to South Carolina. Here we see the umbra from the International Space Station. At that time, a Russian Soyuz spacecraft, seen in the lower right, was the only way to travel to and from the ISS. Since November of 2020, SpaceX has also been transporting astronauts to and from the ISS. These frames from a video show the International Space Station passing in front of the partially eclipsed Sun on August 21, 2017. Notice the sunspots on the surface of the Sun. The annular solar eclipse of last October, photographed by a NASA satellite. The path of that eclipse also passed through Texas. The April 20, 2023 hybrid solar eclipse in a time-lapse video from a Japanese weather satellite. Australia is seen at the bottom center of the Earth here. This eclipse brought totality to the western tip of Australia for less than 1 minute. Totality in a solar eclipse can last for only 1 second, up to a maximum of 7.5 minutes. The April 20, 2023 hybrid solar eclipse, imaged by an unmanned Japanese spacecraft orbiting the Moon. Notice how small the umbral shadow of the Moon appears from 239,000 miles away. You can see Australia just to the left of the shadow. In November of 1966, Gemini 12 astronauts Jim Lovell and Buzz Aldrin took the first photos of a solar eclipse from a spacecraft. Buzz Aldrin did not know then that less than 3 years later he would be the second man to walk on the Moon. A blurry photo of the total solar eclipse taken from Gemini 12, the last of the two-man Gemini missions. Photographing the eclipse was not part of their flight plan, and they did not have time to adjust exposure and focus. Moving at 17,500 miles per hour, they only had seconds to take a few photos through a small window. Apollo 11 astronauts Neil Armstrong, Buzz Aldrin, and Mike Collins photographed this brief solar eclipse as they flew through the Moon's umbral shadow only a day before Neil and Buzz made the first moon landing. The third man to walk on the Moon, Apollo 12 astronaut Alan Bean, snapped this photo of the Earth eclipsing the Sun just hours before they splashed down in the Pacific Ocean. This sight is similar to what you might see if you were on the Moon looking at the Earth during a lunar eclipse. Alan Bean was an astronaut and an artist who painted many of the historic events of the Apollo moon landing program. He even mixed small amounts of lunar dust that he brought back from the Moon into his paints. This is his painting of the unusual eclipse shown in the previous photo. Sunlight filtering through the clouds around the edge of the Earth created a colorful ring around the Earth. The Apollo 12 command module was moving extremely fast, showing Africa at the left side of the early stage painting on the left, Australia is near the bottom of the late stage painting on the right. Do not miss partial eclipse phases before and after totality, especially interesting with a solar or a hydrogen alpha telescope. Observe the disk of the moon covering and uncovering sunspots, solar prominences, filaments, etc. Stay after totality ends. Images of the partial eclipse projected onto the ground by trees. Try using a colander or a piece of cardboard with a pinhole to project images on the ground. Unusual animal behavior, including birds becoming agitated and noisy, insect sounds, coyotes howling, cows returning to the barn, and even human reactions. In the final moments before totality, things will get very busy and surprisingly dark. Watch for shadow bands, the approach of the umbra from the southwest, strange colors in the sky, the temperature dropping, bright stars and planets becoming visible, and sharper, darker shadows than you have ever seen before. Mid-totality, rotate slowly to appreciate the 360-degree sunset all around you. Mid-totality is when you should turn all the way around to appreciate the breathtaking 360-degree sunset effect. In a circle 60 or 70 miles from where you are is light from the partial eclipse of the penumbral shadow. Just before the start and end of totality, watch for the approach and the retreat of the umbra, which will appear cone or oval shaped. This photo was taken moments before the end of totality as the umbra moved away from the observatory. The sky during mid-totality as seen from the point of maximum duration of totality, which is in central Mexico for the April 8th eclipse. The sky will be slightly darker here because the sun will be higher up in the sky. You will not see all of the stars shown here, but you will see the bright planets Venus and Jupiter, and possibly the brightest stars in Orion, Rigel, and Betelgeuse. Although it may not be visible to the unaided eye, a rare comet may be seen to the right of Jupiter. Binoculars may help you see the comet, but remember to only use binoculars during the few minutes of totality. Images of the partially eclipsed sun are often projected onto the ground and on the sides of light color buildings by gaps between leaves on trees that act like pinhole cameras. Holes punched in a piece of cardboard or stiff paper can also be used to safely project images of the sun during the partial eclipse phases. There are many different solar phenomena that are only visible during totality. Although most can be seen with your unaided eye during totality and only during totality, binoculars can provide spectacular views similar to or even better than this. Traveling at almost 1,600 miles per hour, it will take the umbra of the April 8th total solar eclipse only 68 minutes to cross 15 states from Texas to Maine. Detailed maps like this are available at several Eclipse websites. This example shows that eclipse observers in Bloomington, Indiana will experience just over 4 minutes of totality beginning just before 3:07 p.m., while observers in Indianapolis will experience 3 minutes and 45 seconds of totality beginning just before 3:08 p.m. local time. Observers in Louisville, Kentucky will not experience totality at all, although the sun will be 99% obscured by the moon. If you know anyone near, but not inside the path of totality, please urge them to try to get into that path on April 8th. Approximately 31 million people in 15 states live within the path of totality for the April 8th total solar eclipse. Cities within the path of totality, including Mexico and Canada, are shown here, with the size of the red dots proportional to the population of those cities. This is from the excellent GreatAmericanEclipse.com website. It is important to note that some of the largest cities in the path of totality on April 8th, including the top two, Montreal and San Antonio, are near or at the edge of the umbral path. People in those cities should try, if possible, to move closer to the center line of the eclipse path to experience a longer duration of totality. Detailed charts, such as this, are available on several Eclipse websites, showing the important times of the April 8th eclipse for various cities that will experience totality. Fort Myers, Florida, will experience a partial solar eclipse lasting 2.5 hours. First contact will occur at 1:44 p.m. at the 4 o'clock position on the disk of the sun. Maximum partial eclipse will occur at 3 p.m. with 52% of the disk of the sun obscured by the moon. The eclipse ends at 4:15 p.m. Eclipse preparation. Visit and choose your observing location well in advance to avoid unpleasant surprises. Get close to the center line of the eclipse, the umbra's path, but you do not have to be exactly on it. Experience the eclipse with a local astronomy club or attend an eclipse festival. Consider making the eclipse part of a family vacation, not the entire reason for the trip. Identify alternate observing sites and multiple routes to reach them if weather issues occur. Arrive as early as possible at your observing location. Traffic will be congested long before and long after the eclipse. Local authorities may close roads or limit access to popular sites. Prepare as if you're going camping. Bring everything you could possibly need. Because of traffic, it may not be possible to easily drive to a store for supplies. And remember, attitude is the difference between an ordeal and an adventure. This eclipse visitation model shows the estimated numbers of people who might travel to various states along the path of totality on April 8th. The color-coded lines show, for example, that people from Chicago are most likely to drive to Indianapolis to view the eclipse. This map from GreatAmericanEclipse.com website shows estimated drive times to the path of totality. This chart is based on historical weather records and shows the average April cloud fraction along the center line of the total eclipse path. Mexico may have the best chances for clear skies on April 8th. States in the Northeast, including New York, Vermont, and Maine, may have a better chance for clear skies on April 8th. This color-coded map shows that Mexico and Texas are probably going to have the best chances for clear skies based on historical weather records. Maps like this offer tremendous amounts of information and are available on many websites. This map shows counties, which can be helpful in locating smaller cities. Here are 45 years of NOAA weather satellite photos from 1979 to 2023, taken in mid-afternoon on April 8th, the time of the upcoming eclipse. Notice that Texas and Indiana, for example, alternate between cloudy and clear from year to year, so do not be surprised if eclipse chasers in the Northeast have clear skies while observers in Texas see cloud cover. What has happened in the past is no guarantee of what will happen on April 8th. If you become addicted to solar eclipses, and I hope some of you will, here are the paths of eclipses from 2010 to 2060. The next total solar eclipse to touch the United States is on August 23, 2044, but it will only briefly reach parts of Montana and North Dakota. The next major total solar eclipse to cross the United States will occur on August 12, 2045, bringing totality to 10 states from California to Florida. On this map from EclipseWise.com, total solar eclipses are shown in blue and annular solar eclipses are shown in red. This map shows how the width of the umbra, or antumbra in the case of an annular eclipse, varies in width because the complex geometry of every solar eclipse is different. The paths of all types of solar eclipses show that over 1,000 years, almost every location on this planet will experience a total solar eclipse. Every total solar eclipse over North America during this century is shown on this map from GreatAmericanEclipse.com. In 21 years, Central Florida will experience a total solar eclipse with up to 6 minutes of totality in cities including Fort Pierce. Whether or not you are standing in the shadow of the moon on April 8th, NASA TV will provide live coverage all day. This can be especially interesting during the partial eclipse phases before and after totality. I suggest downloading the free NASA TV smartphone app and familiarizing yourself with it now. Finally, these are some worthwhile websites, not listed in any particular order.